Welcome to NOAA Central Library's platform for the presentation of research and ideas in support of the National Oceanic and Atmospheric Administration's mission. My name is Lisa, and I'm your NOAA Central Library host. Today's library seminar is Science to Support Management of a Fishery with Competing Interests, the Atlantic Menhaden Story. The presentation is part of the National Stock Assessment Science Seminar Series, which is developed by NOAA Fisheries and organized by Kristen Blackheart. Today's speaker, Dr. Amy Schueller, will be introduced by Kristen. Before I hand the mic over, here are a few tips about the webinar. If you have trouble with the audio or visual components of GoToWebinar, please log out and rejoin us. This resets the software and usually resolves most technical issues. Our presentation is being recorded and will be available on the NOAA Central Library YouTube channel later today. We will be taking your questions throughout the seminar, but Amy will address them at the end of her presentation. So feel free to type your questions in the questions chat box located in the control panel at any time. So with that last detail, let's start the seminar. The mic is all yours, Kristen.
Thanks, Lisa. So we are so excited to have somebody from the Southeast Center joining us today to talk about some of the cutting edge research that they're doing down there. Amy was actually part of a group that joined us last year to talk about spatial processes and stock assessment methods. And she was so great that we asked her to come back and talk about some more of her research. So for people that don't know her, Dr. Amy Schueller is a research fish biologist at the Southeast Fisheries Science Center in Beaufort, North Carolina. She is one of many Michigan State alumni that seem to be floating around the agency. She is the lead analyst for Menhaden in both the South Atlantic and the Gulf of Mexico. And her research interests include stock assessment methods, ecosystem reference points, and forage fish dynamics. So with that, I will hand it off to Amy to tell us a little bit more about ecosystem reference points.
All right, good afternoon, everybody. Thanks for joining us today and to hear about Menhaden. So as Kristen mentioned, I worked on both Gulf Menhaden in the Gulf of Mexico and Atlantic Menhaden along the Atlantic coast. And today I'm really going to talk about Atlantic Menhaden and basically the journey that basically has been the last decade of my career. There we go. So this talk is basically, I'm going to go through, sort of 5 topic areas, and I'm going to give a little bit of background on Atlantic Menhaden themselves, talk about the competing interests for this particular species. Then I'm going to go through the stock assessment history, leading all the way up to the current assessment and multi-species management, and then talk a little bit about some lessons that have come about. So Atlantic Menhaden, it's pictured here. It is a forage fish species that's commonly found from Florida all the way up through Canada along the Atlantic coast of the United States. The center of its distribution is in Chesapeake Bay. It's a species that forms dense near surface schools, and they tend to aggregate by size, and because size and age are related, thus age. Atlantic Menhaden live along the nearshore and coastal waters of the Atlantic coast as adults, and they reproduce pretty much most of the year. I'll talk about that in a little bit. Once they reproduce, the eggs and yolk sac larvae advect into estuarine environments. This species is estuarine dependent. Once the larvae are into the estuarine environment, they transform into juveniles, and they spend about a year of their life in the estuaries before they then out-migrate and join the adult population. Atlantic Menhaden also have some broad-scale migration patterns. Individuals move northward in the spring, stratifying along the coast by age and size. So larger, older fish tend to move further north during the summer along the coast. This has been verified by one of the biggest tagging studies that was ever completed, if not the biggest. There was over 1 million fish tagged, and the data support that there is this northward movement, and then on the next slide you'll see some southward movement. The genetic studies on this species also support the assumption of a lot of movement and a single coastwide population along the US East Coast. However, a reanalysis of the data that were collected with this tagging study did show that not all of the fish migrate. So the residence rates are a bit higher than what were once thought to be historically. And so each of the regions along the coast has some sort of resident population, but there is quite a bit of movement among the regions. And then in the fall, the individuals move south in the late fall. Not all of them, but some of them move south and overwinter in this sort of colored zone there, which is off of Virginia and North Carolina Capes. For spawning, the Atlantic Menhaden really, some recent work done by Simpson et al. In 2017 showed that they're pretty much spawning almost all the time. So there were eggs and larvae available except for, I think, July and August. And so these fish are spawning up and down the coast, although there's some information indicating maybe it's at different times of the year and as they move. So if they're along the Capes in North Carolina and they're moving north, they may be starting to spawn during that transition period. Or there's also a lot of statements about fish being up north, and as they move south in the fall, they may start to also spawn. And so there's been some ichthyoplankton surveys that indicate that that's true. And so we've got a species here that's a forage fish that is moving quite a bit, spawns frequently, kind of all over the place, and basically has a pretty complex life history that's also dependent upon estuarine systems. And so this species has a lot of interest from different stakeholder groups. And I'll start with the first one. The first one is this species supports a large commercial reduction fishery. And this fishery is the largest fishery by volume on the east coast of the United States. And if you combine the two Menhaden fisheries, they're the largest by volume, or the second largest by volume in the United States. And so these are large vessels that have 2 purse seine boats that are released off of they call it the mothership. And then they set their purse seines around either a school or a part of the school, and that's assisted by spotter pilots, which is in the photo in the lower right-hand side there. So there are planes flying, they spot these schools, and they can radio to the motherships about where the schools are, and then the purse boats can go out and set their nets and harvest these fish. Historically, this fishery supported commercial landings throughout the coast, and so each of these red stars indicates the location of a reduction facility for Atlantic Menhaden, and the bottom star there is in Jacksonville, Florida, and goes all the way up into Maine, and there also were some facilities in Canada as well. Today, there is one remaining facility, and it's located here in the center in the Chesapeake Bay area, and that plant is in Reedville, Virginia. A lot of these plants closed down over the years for a variety of different reasons. In some circumstances, it was, the stock contracting, and so maybe some of the northern plants closed. In other cases, there was some odor of abatement wishes by the local community. If you've ever been anywhere near a Menhaden plant, either on the Gulf or on the Atlantic coast, you definitely can smell that it's there. And so some of these facilities were closed due to things like odor abatement. So the reduction fishery is called the reduction fishery because it reduces the fish into products. And so it's basically once the fish come back to the dock, they are put through the fish factory where there's cookers, presses, dryers, and centrifuges that basically cook down the fish, and it gets sorted into 3 different types of products. And so the first product on the left is fish meal, and this is a mountain of fish meal here, and this is the port sampler here, Brad standing in front of that, and that fish meal is basically the solids that are coming out of processing these fish, and they're used for things like poultry and swine feeds, and more recently aquaculture feeds, and even more recently some equine feeds for racehorses. In addition to the fish meal, also another product in the center here is fish oil. That fish oil can sometimes get dumped back onto the fish meal to have an enriched feed. So it can be a feed ingredient, and also highlighted here is that this is also, again, an aquaculture feed additive. And it happens that the oils from Atlantic Menhaden are high in omega-3 fatty acids, and so those oils are good, of course, for aquaculture feed, but also there's a picture here of the fish oil supplements. It can be found in a few other places on the market commonly, like in salad dressings and stuff like that. And then the other product is fish solubles. So you sort of take in the solids, the oil, and then there's usually some water and soluble component that then also gets back in, dumped back into the fish meal part of it as a feed additive to enrich the meal. So in addition to this commercial reduction fishery, there's also a bait fishery that makes up about a quarter of the harvest along the coast. And the bait fishery harvests Atlantic Menhaden for use as bait for other species such as lobsters, crabs, and other finfish species. And the importance of this Atlantic Menhaden as a bait fish species has increased, especially recently given the reduction in available Atlantic herring for bait. Bait's been particularly important even when the allocation is small. You'll notice here's the allocations by state for the TAC. And Virginia, which is where the commercial reduction plant is, has a large allocation, and then the rest of the states have allocations that are bait allocations. And so you can see New Jersey, Maryland, Massachusetts, Rhode Island, Maine, some of those states are harvesting fish for the bait fishery. So I put this in here just so everybody can kind of get an idea of the historical perspective on the landings for this species. The gray bars are the reduction landings in thousands of metric tons over time. It starts in 1955 and it ends in 2017, which is the terminal year, the most recent assessment. And then the solid black line is the bait landings, and that axis is on the right-hand side there, and that is also in thousands of metric tons, but notice the scale is much smaller. And so you can see there's this increasing trend in bait landings over time, and there's sort of with the reduction fishery, there was 500,000 to 600,000 metric tons being harvested in the late 50s and early 60s, which then dropped off, increased, and then since about 2005, there's been one facility, which is Reedville, Virginia, that's been harvesting over 100,000 metric tons a year. So we've got 2 fisheries. In addition to that, Menhaden's a forage fish species, and a lot of stakeholders are concerned about having enough forage to feed their prey species or predator species of interest. And so some of those predator species of interest include things like striped bass, bluefish, weakfish, spiny dogfish, marine mammals, and birds. One of the things that's difficult about that is sometimes we don't have the best diet data to have good discussions about which species are the most dependent, or which species are reliant on these forage species, and in what areas and in what time of the year. And another part of this has been that the interest in these species has changed over time. Striped bass has always been an interest by stakeholders, but more recently, excuse me, marine mammals and birds have also increased in interest. And so during this whole sort of process, and to get to where Menhaden is now, which I guess I'll get there for those of you who are listening, there's been a lot of involvement from many NGOs that are interested in what's going on with Menhaden, and really it's been with respect to sustaining enough Menhaden for these predator populations. There's big groups of folks that are very interested in fishing for striped bass in particular, and they're very well organized. There's groups of folks who are interested in ecotourism, such as whale watching, and we've had a lot of interest and attendance at all of our meetings by groups that are associated with many of these organizations, such as the Pew Charitable Trust, Ocean Conservancy, the Coastal Conservation Association, Menhaden Defenders, the Theodore Roosevelt Conservation Partnership, and others. So the Menhaden story, this is my sentence. I've loved this sentence. So we layer complex life history and competing interests with conflicting stances in forage fish science, and at that time, no defined goals and objectives. And so at that point, which I'm really talking about basically time period around 2013, where the Menhaden board had asked the science groups to start working on some of these ecological reference point topics. And so during that time, we also had a lot of reports and science coming out regarding forage fish management. In 2012, the Lenfest forage fish report came out. That task force had worked on providing information on how forage fish should be managed based on a group of evaluations of a bunch of EWE type models. And then in response to that, Hilborn et al. Put out some papers and responses and videos, and I have a video link here if you're interested in watching that another time. And so Menhaden actually kind of got caught in the middle of this discussion as we were trying to move forward. And the other part of this is no defined goals and objectives, and I'll talk about that in a second. So Atlantic Menhaden is managed by the Atlantic Menhaden Management Board. That board is part of the Atlantic States Marine Fisheries Commission. This is part of the interjurisdictional fisheries component of the National Marine Fisheries Service, and I'm in the Beaufort laboratory in the Southeast. We have a really long history of working on Menhaden. There used to be several Menhaden plants in our location, and so we've been working with ASMFC for quite a while. The board itself has 3 members from each Atlantic coast state. I think there's 16 states, also members from the Potomac River Fisheries Commission, the U.S. Fish and Wildlife Service, and then also the National Marine Fisheries Service. And until 2013, when they set a total allowable catch, so a coastwide quota, there were basically very few regulations on Atlantic Menhaden. And at that time, when they set that quota, they basically asked us, or were saying things like, we would like more fish in the water, which isn't very clearly defined. I'm a numbers person. I'm a stock assessment scientist, so I'm kind of sat there and thought, well, how many fish do you want, and in what time period, and do you want them to be a certain age, et cetera, et cetera. So there's a lot of questions that brings up. And so that leads me to the stock assessment history. And I guess I'll start with that, with the 2014 stock assessment, but I'll also mention some previous work. And so for the 2014 stock assessment, the management board charged our technical committee and the ecological reference points work group to provide ecological reference points for Atlantic menhaden. At the time, I thought to myself, well, I don't know what that means. And so it took a lot of work and time, because I'm giving this talk, it's 2021. So basically, you could think of this process as taking from really 2013 to now in order to really come to fruition. But actually really started even way before that, because it's been an ongoing process to account for the forage role of menhaden. So in the late 1990s and early 2000s, there was a multi-species VPA that was worked on, that they tried to look at the diet components for menhaden. And in the past, in assessments, that MSVPA was used to provide natural mortality matrix, so a matrix over time and across ages, in order to use that information on changes in natural mortality in the single species stock assessment. However, during the 2014 assessment period, the MSVPA was abandoned due to a mismatch in the estimated time series for menhaden and the lack of a predator-prey feedback mechanism. There were just some issues that we weren't really able to resolve, and thought that there were maybe some better tools or options that could be used to move forward with this. Fast forward to, so 2014, we did CDAR 40. CDAR is the Southeast Data Assessment and Review. It's basically the process by which stock assessments are done in the Southeast region, and they're numbered sequentially. So this is CDAR 40. We were given a term of reference, number 7, to identify potential ecological reference points that account for Atlantic menhaden's role as a forage fish. And at that time, the work group wasn't able to complete that task completely, but what we did do was we proposed several tools that could be used to address that. And so I put here, finalized ecological reference points were not developed in time for CDAR 40, and I put in here again, given management objectives were not defined, and that additional technical work and peer review would be necessary for them to be available for management use. So basically, basically we went ahead and said, here's some tools, here's some options. We really need the management board to tell us what their goals and objectives are, so we know which tools we can use to address those, and if we can address those goals and objectives. And so when this assessment was reviewed in 2014, December of 2014, the Center for Independent Expert Reviewers, CIE reviewers, agreed with the technical committee and work group members in that the board needed to work to define what their goals and objectives were. And because of that, we were able to use the leverage of those review comments and our own comments to have an ecosystem management objectives workshop for Atlantic menhaden. That was held in the fall of 2015. There was a subset of board members, stakeholders, including the fishery and NGOs, as well as scientists that were sitting at the table. And during that 2-day meeting, we defined goals and objectives for ecosystem management. And that was a huge step for us, because it allowed us to go back and then evaluate which ones of these tools would work in order to get at some of those objectives. So I'll just give you some examples. There's a report on ASMFC's website if you'd like to look at it. It has all of the objectives that were defined during this workshop, but here's a few just to sort of get a flavor. So some of the objectives were things we wouldn't necessarily be able to address in a model like a stock assessment model. And one of those is the example at the top here, achieve broad public support for management. Other options for objectives were things that we would be able to address or provide guidance with the tools that we had available. So some of those things included sustaining menhaden to provide for fisheries. So that meant both fishery for Menhaden, but also fisheries for these other species of interest. In the way that basically we would be providing forage for predators here. They're also interested in ecosystem services, maintaining stability for all of the fisheries, minimizing risks due to changing environmental conditions. They basically wanted stability, resiliency, and for there to be fisheries for both Menhaden, but also predators, and for everything to be sort of healthy. There's a number of other objectives. And after we talked about the objectives, we also talked about ways you could actually measure the things that they were interested in order to evaluate whether or not we were meeting those objectives. After that, the ecological reference point work group, so the ERP work group, used those objectives from the report and the CDAR 40 peer review to go ahead and identify the objectives and performance measures that we could address using the models and approaches that we had outlined. We also assessed the ability of each of those models or tools to address the management objectives and performance metrics, and then we made recommendations on the appropriate tools to move forward. And this is all under the purview of the assessment that was completed in the December of 2019. And so we worked on this from 2017, maybe the end of 2016, all the way through the end of 2019 when it was reviewed. And we basically went through a model selection process, and we selected models based on their ability to address multiple objectives, their ability to predict and monitor performance measures, their technical merits, and their adherence to our CDAR recommendations from the reviewers during that CDAR 40, which were to not go for the biggest model that includes everything we could possibly consider, to go for something that provided what we needed but wasn't sort of too cumbersome. So a minimum sufficient complexity model, and that's where we landed. And so this is, don't get hung up necessarily on the what's in each box here, but there's basically, this is fundamental objectives, some performance measures, and then each of the different models or tools that could be considered and which ones addressed which component pieces. And so there's an example, sustained menhaden to provide for fisheries, and we can measure that by looking at the abundance or biomass of menhaden over time. And all of the models that are listed or the tools here are able to address that. Alternatively, things like sustained menhaden to provide for predators, we could look at the abundance or biomass of predators. We can only do that in a multi-species type of model. So getting to sort of where we're at now with the assessment and multi-species management. So fast forward to 2018, 2019, the Stock Assessment Subcommittee for Atlantic Menhaden and the Ecological Reference Point Work Group basically worked to prepare data and configure the single species Atlantic Menhaden assessment, but also the additional assessments to consider the ecological reference point options. And so there were 6 models in total that went to review for this, the first of which was the single species assessment model. There were 2 surplus production models. One was a model that had a time varying R component, so it allowed for changes in productivity over time, but didn't necessarily have a mechanism. The second one was a surplus production model that had more than 1 species in it. The third multi-species model, or the 4th total model that went through for review here, was a statistical catch at age model that had multiple species in it. And then there were 2 additional models based on EcoPath with EcoSim, or EWE models. Those EWE models were of 2 different tiers. So we had one full-blown EWE model, which I think had like 61 species and species groups in it, although don't quote me on the number. And that one had everything in it. And then we had a what we called a mice model, or sort of this intermediate complexity. We were trying to get at that the reviewers said, you know, minimum sufficient complexity. And so we had a pared down EWE model that really focused in on the species of interest, and those species were aligned with what was in the multi-species statistical catch-at-age model. And then the question became, okay, we have a single species assessment and we have these 5 other tools, and how do we combine them to provide some sort of management advice? So the first step in that was, well, how do all these models look? Like, do the tools provide us with the same information about the stock itself? And so this is 4 plots, and the 2 on the left are age 1 plus biomass, and they're either on the top millions of metric tons or scaled to the mean on the bottom. And then on the right is exploitation rate, and the value for the exploitation rate is on the top, and then scaled to the mean value is on the bottom. And this is over time, so the x-axis here is just time. And so the black line with the little star and it says BAM, it's the Beaufort assessment model. That is the base run of the single species stock assessment model, and the gray shaded area is the MCMC output for some uncertainty bounds. And that is the single species assessment. So the other colored lines, there's 2 EWE ones, they're the pink and the green, and then the Vader, which is the multi-species statistical catch-at-age model, is an orange, and then the 2 surplus production models are in a sort of that mustard yellow and blue color. You'll notice that the statistical catch-at-age models both have a bit more variability and ups and downs, and that's because we're tracking ages and cohorts differently than what's being done in the EWE models. But what the main point of this is that in general, we were able to, in all of these tools, show very similar trends in what's going on with the population over time. And so that was a good thing. We were able to then figure out sort of which ones of these we would use in order to provide some tactical management advice. So I just said this, models are fairly congruent given the different assumptions and data inputs, and our recommendation ultimately was to use the single species model in conjunction with that MICE EWE, so that minimum sufficient complexity or the intermediate complexity EWE model. And the reason for that was it provided the information that we needed on other species of interest. It wasn't overly complicated. It had fewer data inputs than the full EWE, and it addressed the goals and objectives that were outlined by the management board. And so for that assessment, there were a lot of different iterations that could be provided with. I mean, if you are an assessment scientist, you know there's lots of ways to, and lots of iterations within a single species assessment. Now, if you multiply that by multiple species, there just becomes sort of this infinite way to look at what the different options are. And so what the ERP group did was provided an example of how the tool would be used, and then the board could provide some further guidance about what they wanted to see in order to make their management decisions. And so this figure, I'll take some time and orient everybody. So the x-axis for this figure is the Menhaden fishing multiplier, fishing mortality rate multiplier. And the y-axis is the striped bass fishing mortality rate multiplier. And so the single species and multi-species fishing mortality rates are slightly different. And so there's this like conversion between them. And the colored part of the figure here is the striped bass biomass over the biomass target. And so if your biomass for striped bass is above the biomass target, you're in the yellow, greens, blues, and purples down here. And if your biomass is below the target, you're in the reds and oranges. And so the F, so the fishing mortality for 2017 is these dashed lines. So this is the fishing mortality rate was set to 1 here, or when we're doing those conversions, it's 1 in this figure from Atlantic Menhaden. And then here it is for striped bass at 1. And basically you notice with this is the current fishing mortality rate for striped bass. If you go across the different fishing mortality rates for Menhaden, you're always in the red or orange, which means basically no matter what you do with the fishing mortality rate for Menhaden, striped bass are still not meeting their biomass target. In fact, they're not even meeting their biomass threshold, which are these 2 solid lines here. And so one of the things that we were able to say out of this was, well, they need to make some changes in their striped bass management. So if they reduce their management to the F target, which is the dotted lines here, F target. If you reduced your striped bass so that the fishing mortality rate was at the F target, which is this dashed horizontal line, then you can in fact impact some changes in striped bass biomass with changes in Menhaden fishing mortality rate. And so the question becomes sort of where does the board see themselves? Where do they want to be? Do they want to be at targets? Do they want to be at thresholds? And there's some different options there. And so we call this the rainbow chart, and you can kind of produce these for a bunch of different options. This one in particular is produced for basically all the other species in the multi-species model being at status quo for 2017, and then running this across different fishing mortality rates for striped bass and Menhaden moving forward from 2017. So how do we kind of do that? This is the a plot of the biomass in million metric or million. I don't think that's supposed to be metric tons. It's basically striped bass age 6+ biomass, and looking at that over time, there is a B target and a B threshold. And basically we're saying if we run and project this forward across a different gradient of Menhaden fishing, so this is the Menhaden Fs here from blue to red, where do we land? And so if we fished at F current for Menhaden, which the numbers are here, this solid black line brings us all the way back up here. If we fished at the fishing mortality target or threshold, so those are the black lines either dashed or dotted for the single species stock assessment of Atlantic Menhaden, this is where striped bass would be. So this is if we were at the Menhaden threshold and Menhaden target. But if we defined our fishing mortality rate for Menhaden such that we said we want the rate at which we can fish and be at the target or threshold, that gives us these 2 red lines, the red dotted or the red dashed. And again, threshold versus target, depending on where management wanted to be. To kind of slice that and look at it a little bit differently, this is like a flat slice through that last figure. If we look at Menhaden Fs and then the striped bass biomass over the biomass target, and we're going to be on this line somewhere, we would say, okay, where do we fall? And so the F current at the end of the terminal year of the single species assessment was this gray line. And the target and threshold for the single species assessment are defined by these 2 blue lines. And then for our example ERP, again, where everything was status quo except striped bass and Menhaden, we said, well, if we're going to fish at different rates, where would the targets and thresholds need to be in order to be sustainable for striped bass, basically. And so here's the threshold. Notice it's less than the single species, and the target is as well. So that was one of the findings. It's in line with other research that's been done that basically says that ecological reference points are typically less than the single species reference points. So I put up here multi-species management, and I put it in quotes because in my viewpoint, I think if you asked a fishery scientist, like, what do you think or really any scientist who works on sort of any organism, what do you think multi-species management looks like? They'd have this sort of dream idea of like every option is a knob to turn. Like, not only would we be turning menhaden, we'd be turning striped bass and bluefish and marine mammals and et cetera, et cetera, et cetera. So in reality, what's going on here is more of like a single species management in the context of other species of interest, which is still, a facet of multi-species management, and it's a huge step forward. And so it's pretty exciting because we are moving from sort of the single species assessment framework into a framework where we're interested in preserving prey for other species. And so the current management structure isn't really set up for the process of doing full multi-species management. The Atlantic States Marine Fisheries Commission has boards for each of their species, and they don't really meet together. So for example, the striped bass management board and the Atlantic menhaden management board, they don't meet together to define their goals and objectives and set their reference points for the species together. Now, there are some members that are on both boards, but in general, they don't do that. And so the commission and the board could work towards having that type of a structure, and that would really improve management's ability to be flexible and move towards this sort of dream notion of multi-species management, as a lot of people would picture it in their heads. So I feel like I've run through a whole bunch of stuff in this sort of long-winded story, and this assessment was approved in 2019 and published in 2020 through the CDAR website. You can go on the CDAR website, and I think it's CDAR 69, and both the documents for the single species assessment and review and the multi-species assessments and reviews are on there if you are interested in taking a look. And I guess I put this up here because what happened after that. And so both the single species assessment and the multi-species modeling frameworks were presented to the management board in February of 2020. And both of them were accepted for use in management. And so that was fantastic. The board went ahead and adopted the ecological reference points for management use in August of 2020. And then in October of 2020, they went ahead and set a TAC, a total allowable catch or quota, for the whole coast based on that work. And so during this year in 2020, there was a lot of requests for, okay, run the EWE in these different ways, and then go ahead and run projections for the single species assessment based on those outputs. And so I guess I didn't really say how the two were combined, but basically we're projecting forward the EWE into the future to basically get a level or a fishing mortality rate that they were then putting back into the single species projections to see what that total catch should be. So this has been implemented in management, and it did result in a reduction in the quota for 2021. So some lessons learned, and I think that the process by which this was completed is a process by which other species or species complexes could use to work toward implementing something like this. And so we've sort of tried to think about what we've learned along the way. And so single species assessments is key to putting together ecosystem models. And so our ecosystem models were built off of all of the single species assessments that were put together, of course, including menhaden, but also striped bass, bluefish, and as well as many, many others. This process would not have been successful if we had not maintained a strong working relationship with the board. So during this whole time period from basically 2014, really 2013 to the present, we have updated them as to what's going on. They have, answered questions so that we could keep moving forward. It's also difficult to balance stakeholder needs and wants. The stakeholders don't always have the same wants, and they often have competing interests. And so you're kind of, getting at the sweet spot of, I guess, making everybody happy and everybody unhappy at the same time. Data are lacking in some areas. I think that can be said about almost every single thing we ever work on in science. So it's just sort of one of those statements. We need more data. In particular, we're very interested in developing better diet data, and both spatially and temporally. Other lessons learned. So I put time of staff and scientists on here. So I'm particularly I guess lucky as a federal employee. I work on Menhaden. I'm not working on, 4 other species. Many of the folks, the scientists that were involved in this process, work for the states, and Menhaden isn't their only species. And so it's hard sometimes to get things moving and rolling, but this is a fantastic group of people, and I'll acknowledge them at the end, that really works well together and I think produced a pretty great product. Let's see, next one, uncertainties surrounding the outcomes. So we always discuss uncertainties in our single species assessments. And of course, there is even more uncertainty in our multi-species assessments. And so we just need to keep that in mind as we're moving forward. And then the last thing I have on here is embrace incremental steps. I think sometimes we lose track of that. And during this whole process, which took several years, we did make some great incremental steps, which basically allowed us to meet our overall goal. And sometimes I think that when these goals or questions get asked, it can be somewhat overwhelming as to like, how are we gonna get that done? And I just think it's pretty critical to embrace incremental steps, set like a roadmap up, have goalposts, work toward them as a group, and eventually you'll end up where you want to be. If folks are interested in learning more about Atlantic Menhaden or the process or the models that are involved in this, there's a couple papers that have come out just recently from all of this work. So I listed here, there's a paper by Schueller et al., and it is titled Ecological Reference Points for Atlantic Menhaden Established Using an Ecosystem Model of Intermediate Complexity. Basically, that's the paper on the minimum sufficient complexity, or MICE EWE model. So the model that we ultimately paired with the single species assessment in order to provide management advice. There's a paper by Drew et al. That looks at the model complexity, data requirements, and then meeting those management objectives. And those comparison plots that I showed of the different models are in that paper, and we're basically just providing some recommendations about differences in model complexity and how things can still line up and provide us with a suite of useful tools in order to enable us to answer these types of questions. And then there is another paper that's in review still, and that one is like a story, more of a paper that's like the history of how we got where we are. And so hopefully stay tuned for that one. The final paper on this slide is Howell et al. And Daniel Howell is a Norwegian scientist who worked on another similar problem for the Irish Sea with a group of folks, and happened to be one of the reviewers for our stock assessment. And basically, this paper is advocating for the use of combining ecosystem and single species models to provide tactical management advice within the current management framework that we have. and that we can do that. It is feasible, and we use sort of Menhaden and the Irish Sea examples as case studies. Interestingly enough, we sort of those two groups worked independently, unbeknownst to one another, and sort of ended up in the same spot as far as how to make this work. So I'll just end with some acknowledgments. This work is, basically done by an army of great people who, yeah, I can't speak highly enough of them. So through the Atlantic States Marine Fisheries Commission, there's a number of staff that help with the work groups. And also ASMFC has their own stock assessment staff. And so those people are Kristen Anstead, Max Appelman, Katie Drew, and Sarah Murray. And Max has left the commission now, and I think he's a NOAA employee. And also with ASMFC, the Atlantic Menhaden Stock Assessment Subcommittee, those people are listed here: Joey Ballinger, Jason McNamee, Ray Maroc, Alexi Sheroff, Micah Dean, Matt Sierri, Rob Latour, Jeff Bruss, and Chris Swanson. Some of the folks have an asterisk by their name, and that's because not only are they on the Atlantic Menhaden Stock Assessment Subcommittee, they're also in the next group, which is the Ecological Reference Points Committee. So all of those with the asterisks, plus Dave Shigaris, Jim Uphoff, Shanna Madsen, Mike Celestino, Howard Townsend, and Jason Boucher are in that group. And then the last group of people I have here are Jenny Nesledge, Mike Wilberg, Andre Bukeister, Joanna Brito, and Max Greslick. Those folks provided, they were external to the ASMFC committees, but they provided some of the other models. So Jenny and Mike worked on the surplus production model with time varying R, and then Andre and Max and Joanna worked on the EWE models. And with that, I'll take questions.
Thank you so much, Amy. That was a great presentation. Audience, we have about 8 minutes for questions. So if you have any questions, please type them in the questions chat box, which is in your control panel, and I'll read them to our speaker. Also, before I read this first question, if you're interested in today's slides, you can download them from the handouts menu, which is also in your control panel. So Amy, we do have a first question. I put it in your chat box, but I'm going to go ahead and read it as well. Do you think that the Southeast Fisheries Science Center will be able to get more diet data similar to what we have in the Northeast Fisheries Science Center? I think diet data, i.e. estimate of predation mortality, will certainly improve ERPs.
So first I'll say, yes, I completely agree with you. I do think diet data will help improve estimation of predation mortality and estimation of ERPs. The diet data that were used for this work were mostly from the Northeast Fisheries Science Center and from another program, NEMAP. And so Atlantic Menhaden runs from Maine to Florida, so it's really a coast-wide a look at things. I will say the Southeast region has, sort of the lowest level of fishing mortality. The reduction fishery doesn't really fish south of really Virginia at this point, but it was North Carolina in the relatively recent past. The bait fisheries in the southern part. So it would be nice if the Southeast Center would be able to collect diet data, but I don't foresee that happening anytime in the near future, unfortunately. But NEMAP does come, I don't know what the furthest southern extent of their range is, but I could look that up and get back to you about that. They're actually ongoingly collecting data.
The person who asked the question said, sorry, I mean mostly from the south. Just if that helps. So we have another question here. I've also entered that into your chat. Were the different interest groups happy or at least equally unhappy with the outcome of this assessment?
Yeah, I think that some of them are happier than others. So I think that the folks that are really interested in preserving Menhaden as a prey source are fairly happy. You know, we went through all of this and provided those ecological reference points. The management board acted on that. There is a reduction in the quota in 2021. So I think they're fairly happy. I think that the bait and reduction fisheries maybe aren't as happy, which you would expect, right, with a reduction in a quota. I think that part of the reason they might not be as happy, though, is more related to like the risk of the board. So the management board's purview is defining, you know, how risky they would like to be with their management. And so in the federal system, a lot of stuff is really managed a lot closer to the threshold. And in this particular instance, they're managing to, you know, to the target. And so the level of risk that the board is willing to take with respect to the target probably isn't as risky as the fisheries would probably like it to be.
Excellent. So audience, we have about 4 more minutes for questions. So I encourage you to ask them now before we end the webinar. And while I wait for more questions, I want to also encourage you to share the recording of this webinar with interested colleagues. We are recording today. So I will upload the recording to the NOAA Central Library YouTube channel, and it will be available in a few hours. While we wait, I wanted to find out if, oh my goodness, we just got a whole bunch of questions actually. Let me go ahead and send you some of these. So this first question asks, do you have any advice or opportunities for students or early career professionals who are interested in stock assessment science and looking to gain relevant experience?
Sure. So early career or students. So I'll start by saying all of the meetings that we had for this entire process are open to the public. And so if you're a student and your advisor like would support your attendance at that kind of stuff, we do have students that do come sometimes from some of the local colleges. So there's that. There's lots of opportunities within NOAA in order to apply for internships at the college level. And so those types of things, if you apply for them and you're selected, you could work on an assessment type project. So I've had, I think, 3 or 4 interns over time that have come in and worked on different Menhaden projects. So there are opportunities. You just kind of have to know where to look or find the right person. And whoever asked that question, I put my email address up here. You can feel free to contact me and we could chat about that a bit further.
Great.
And
I have,
sorry
go
to
ahead.
interrupt. This is Kristen. I can reach out with some more information on that as well after the webinar.
Thank you.
Yeah, that's a great question. I do have one last question that I wanted to ask. This is great work, Amy. Really pleased to hear that the board accepted some ecosystem approach to Menhaden fishery. Now that we are all talking about climate change, are we considering any environmental information in stock assessment, i.e. adjusting ERPs to account for climate change?
That's a great question. I actually just had a call on Tuesday talking about climate, environmental variability, and adding a spatial component to this assessment. And so, with the spatial component, of course, comes the temporal component. So the management board's definitely interested in scoping out what we would need and what data would be available or would need to be collected in order to move from what we have into something that has more information spatially and temporally. And then they've really always been interested in sort of environmental changes. And so some of those things are somewhat implicitly included, right? So this stock assessment has time varying growth in it. and Atlantic Menhaden sort of have this sine curve type growth occurring over time. So there are some things that are included to try to hopefully get at some of those things like implicitly, but not explicitly at this point. But we always talk about it, and we definitely just did a scoping call to provide information to the board for moving this forward even further.
Okay, excellent. Unfortunately, we've hit the hour. We do have 3 other questions, but you know, we're not going to ignore your questions. I'm going to send these all to Amy so that she can address them offline with everyone who's asked them. Any last comments?
No, just thank you everybody for attending and for listening. And if you have any questions, I'm happy to have everybody send me an email and I'll get back to you.
Excellent. Well, thank you very much for your presentation, and to Kristen for organizing the National Stock Assessment Series. Audience, I'm glad you joined us for today's library seminar. NOAA Central Library is very proud to present the work of the NOAA community, and we hope that you'll join us again. So be well all.